In the previous video, we looked at the fundamental theorem of calculus, part 1, and we proved it. Now we're going to prove the part 2, the part most people use more commonly, the one that allows us to do something like, if we have x squared dx, we can do 1/3 x cubed, and it goes from 0 to 1. We can go from 0 to 1, and we get the area under the curve of a parabola from 0 to 1 is 1/3. It's what allows us to do that. So let's look at how to prove it. First, let's write down the formal statement. So the formal statement says we have to put some conditions. If f continuous on AB, closed interval AB, then integral a to b of f of x dx equals f of b minus f, let's write it over here, minus f of a, where big F is any antiderivative of small x, and that means that how f of x and f of x are related is that f prime of big F prime is equal to little f. So we know that. Let's try to prove it. So the first thing we're going to look at during the proof is that we're going to define a function g of x, which is going to be defined by integral from a to x of f of t dt, like we did in the previous fundamental theorems of calculus. So now we're going to say that any other antiderivative, so we know that g prime of x equals f of x. So we know that g is an antiderivative of f. So what else do we know? If big F of x is any other antiderivative of small f, that means that g and f have to differ by only a constant, right? Because if we have graphs, if we have this graph and the derivative is something, then if we have this graph, that has the same derivative because it's just moved up and down by a constant. So because of that, we see that big F of x equals g of x plus some constant c. So that's going to be an important note later on. So now what we're going to do is we're going to take g of a, and we're going to put that. So remember, g of a is going to be from a to a of f of t dt, and that's going to give us 0 because it's going from the same point to the same point. So if we're going from the same point to the same point, and g of a, remember g of x was defined as, or rather, f of x was defined as g of x plus c. So if we do f of b minus f of a, we're going to get g of b plus c minus g of a plus c. So let's write that up here so you can see. So we're going to get g of b plus c minus g of a plus c, and put the brackets in the appropriate places. So we can see the c's are going to cancel out. It's going to be g of b minus g of a. But we know g of a is 0, so this is just equal to g of b. And that is just going to be equal to a to b of f of t dt. Okay? So what have we learned from this result? So the full result says that big F of b minus big F of a, and big F was just any antiderivative, remember that, equals the integral from a to b of f of t dt. And that is exactly what the part 2 of the fundamental theorem of calculus says.